Alright, so for this next part, we're going to talk about how to go back and forth between polar coordinates and rectangular coordinates. So we already learned that a polar coordinate has an r and a theta, and of course a rectangular coordinate is just one in terms of x and y. So we have some formulas down here at the bottom to help us out. So if I already have if I already have polar and I want to go to rectangular, I'm going to use these right here. So I can use r cosine of theta to get x, and I can use r sine of theta to get y, which should look very similar to what we did with vectors as far as cosine being x, sine being y, and of course the same as our unit circle. So that's going to be our first problem. It tells me that this is polar coordinates and I want to change this to rectangular. So that means that this is an r, this is a theta. So x equals r cosine theta and y equals r sine theta. So x is going to equal 3 cosine of 3 pi over 4. Y is going to equal 3 sine of 3 pi over 4. Okay. Well, using my unit circle, I know that cosine of 3 pi over 4 is the same thing as negative pi over 2. And sine of 3 pi over 2 is positive square root of 2 over 2. Okay, so again we get those from our unit circle. And then if I simplify that a little bit, I just say, oh, well, this is negative 3 square root of 2 over 2. And this would be just positive 3 square root of 2 over 2. And then lastly, I always write coordinate in parentheses. So my answer should be negative 3 square root of 2 over 2, comma, 3 square root of 2 over 2. So I went from a polar coordinate to a rectangular coordinate, one with r and theta to one with x and y. Go ahead and try numbers 6, 7, and 8. Pause the video now, and then I'm going to go over the answers for those three before I move on to the next problem I'll do, which is number 9. Alright, so for number 6, you should have gotten negative 3 over 2, comma, negative 3 square root of 3 over 2. For number 7, you should get negative square root of 2, comma, negative square root of 2. And for number 8, you should get 1/2, comma, square root of 3 over 2. And then that brings us to number 9. Number 9, we're given rectangular and asked to find polar. So we're going to work backwards. This is going to look very similar to when we did this with vectors. We did something very similar to this as vectors. So if I were to look for my formula we had earlier, it says r, down here, r equals the square root of x squared plus y squared. So let's do that one first. So r equals the square root of x squared plus y squared, which for our problem means 1/2 squared plus negative square root of 3 over 2 squared. If I actually square those out, I get 1/4 plus 3 over 4 because the square root of 3 squared is 3, 4, and 2 squared is 4. So both of my numbers are 4. Add those two together and I get 4 over 4. Well, 4 divided by 4 is the same thing as 1. And the square root of 1 is just 1. So I get r equals 1. And for all of these, r should be a whole number, probably 5 or less. So you should get 1, 2, 3, 4, 5 for your r values. It should be a whole number, single digit positive. It specifically tells me that r is a positive number up here. Okay, so for my answer, my coordinate point, I already know the first part is 1. That's my r. I need to find the theta. Now, this formula tells you can use tan of negative 1 y divided by x, and that works. The problem is I'm going to want to use my unit circle on this, and I can find tangent using my unit circle, but not nearly as easily as using cosine or sine. So I'm actually going to do this a little bit differently. I'm going to use what we were given, and it doesn't really matter if I use the x or the y. I'm specifically going to use the x just because it's 1/2 and doesn't have a square root in it. So I'm going to say x, 1/2, which is x, equals r cosine of theta, which was the equation we used just a second ago. So there's my x, and we know that equals r cosine theta. Well, we just found the r. We know that the r is 1. Well, 1 times cosine of theta is just cosine theta. So you can just look at this and think, okay, well, where does cosine of theta equal 1/2? And so, or I could even do this. All right, so by using this, I end up with, I'll plug that in my calculator, 60. And I could look at my unit circle and say, oh yes, cosine of theta does equal 1/2 at 60. But there's a problem with this, and that is my coordinate point. I have a positive and a negative. Well, a positive and a negative occur in the fourth quadrant. And the fourth quadrant is for angles between 270 to 360, which 60 is not. So there's a couple different ways you could do this. If you were going about it this way, you would just say, oh, because it's in the fourth quadrant or the third quadrant, I do 360 minus that angle and get 300 degrees, which is correct. Or you could just use your unit circle and just think, okay, well, in the fourth quadrant, where does cosine equal 1/2? And if you use your unit circle, you'll see that cosine equals 1/2 at 300 degrees. So either way, you get that answer. So make sure your angle matches up with the quadrant your coordinate point is located in. Go ahead and pause the video here and try the next 3 problems, and then I'll show the answers in just a second. Alright, so for number 10, you should get 3 and then 5 pi over 4. For number 11, you should get 3, 5 pi over 6. And for number 12, you should get 1 7 pi over 4.